case control studies are particularly vulnerable to selection bias because the exposure and the disease have already been developed by the time the subject is recruited into the study. So selection bias occurs in a case control study if it can occur in the selection of the cases as well as the controls. So in the case of the cases, selection bias occurs if the selection of the cases is not representative, or the cases selected for the study are not representative of all the cases in the population. So if there's some unique feature of the cases in the study that's not generally true of cases in the rest of the population. And then similarly with controls, if the controls are not representative of the population from which the cases came, then that represents a selection bias. And so in either of these cases, the relationship between the exposure and disease that is estimated from the study data will not be an accurate measure of the relationship of the exposure to the disease in the population, which of course is what we're interested in. So now I'm just going to give you an example of what this might look like in an actual study. Okay, so in this study what we're interested in is understanding whether heavy alcohol consumption is a risk factor for the development of liver cirrhosis. So as in any case control study, we start with cases. So we have our cases of individuals who have developed liver cirrhosis. So of course they all have the outcome that we're interested in. And now we have to come up with a control group, okay? And so what we're going to do in this study is we're going to come up with a control group that is from the trauma ward of the hospital. So this happens frequently. It's easy to do a case control study in a hospital. Often you have medical records that you can use. And so you just have to figure out where in the hospital do you get your control group patients. And so in this study what we did is we got our control group patients from the trauma ward, okay? And so now, as in any case control study, what we're going to do is look at the odds of the exposure of interest, in this case alcohol use, heavy alcohol use, in the cases versus the controls. So here is our data. So we have the exposure, the cases and the controls broken down by exposure, and so this shows the exposure. So we're going to calculate our odds ratio. So of course we know that we calculate the odds ratio by multiplying these these cells, so that 80 times 60, and then that's over 20 times 40. That's just the formula for calculating odds ratio, which is 4,800 divided by 800, which equals 6, okay? So the question here is whether our control group was representative. So we have an odds of 6, meaning that the odds of heavy alcohol use are 6 times higher in the case group than they are in the control group. And so what's important to know is whether the control group is representative of the population from which the liver cirrhosis cases came. And so we might notice here that we can see that there's a very high proportion of of cases who have been exposed to heavy alcohol use, and similarly in the controls, there's a less high exposure, but it's still pretty high. 40% have been exposed to heavy alcohol use. So we want to know, we always want to consider in the control groups in a case control study or any study, they should be representative of the overall population. Not the population of cases, but the population from which the cases emerged. Okay? So this would be more like the general population. So this might be a little too high. So now what we do is we look at a different control group, and this time the control group is still taken from the hospital, but it was taken from a non-trauma ward. And so let's calculate the odds ratio here. We see that the proportion exposed to alcohol use, heavy alcohol use, is much lower in this non-trauma ward population than it is in the trauma ward population. So when we calculate the odds ratio, as we do down here, we find that the odds ratio, when you compare the cases to control B, control group B, which is people from the non-trauma ward, you get a much higher odds ratio of 36. And so what this shows is that the first group underestimated the odds ratio because the control group had a higher, let's say, incidence or prevalence of the exposure than did the general population. And so because of that, it underestimated the extent to which the exposure was related to the cases. So that's an example of a selection bias that in particular case control studies are vulnerable to because because you have to create your own control group, and that's really hard to do without knowing what kinds of factors are related to the development of the outcome. And the selection bias occurs when your selection of cases and controls is related somehow to the exposure and therefore biases the relationship between the exposure and the disease that is estimated by the study.